Now we talk about the proportion. So we know proportion is a z-test, so test the difference of proportion. Again, the same thing, because proportion is a normal. Difference of two proportion also normal, because minus difference between normal is a normal distribution. So the null hypothesis is the different proportion is a number A, and A of course is between 0 and 1, and they are not the same. So given occurrence x1, x2, samples are n1, n2, the sample proportion are x1 over n1, x2, p2 is x2 over n2. Then the z-test statistics, right? This will be normal distribution with mean 0 and variance 1, standard normal. So p1 minus p2 equal to pi 1 minus pi 2 is the standard error will be p prime, p bar, 1 minus p bar, and 1 over n1 plus n2. Whereas p bar here, p bar is x1 plus x2 over n1 plus n2. So this is overall occurrence and overall sample, right? Because there's no difference, so that's why this is the best estimate. And the critical value, of course, is normal, so it's alpha over 2 of z. So I have two tail, but one tail and will be the same thing, right? Because you see alpha and it's a right tail, is left tail is negative z alpha. Okay. The common interval estimator would be p1 minus p2 and plus minus, okay, and z alpha over 2. And this one we have p1 1 minus p1 over n1. Okay, this one is a little bit less sharper than this one, right? Because this one we under the null hypothesis we assume that would be p bar, right? So but this one we cannot make such assumption, so this one the interval much larger. So consider proportional tests, right? Two-sided. So if a two population and random sample of size 50 from one population of sample proportion 0.6, the other sample from another population of sample size 40 has sample proportion 0.7. So we say they're the same for the null, they're different, right? So that's why that means p1 minus p2 is 0 in this case. The pool proportion, right, will be, this is number of occurrence, right? So that's why it's p1 times n plus p2 times n2, n1 plus n2, right? So it's 85 over 90, right? The z-test statistic will be the difference between them, because which is difference 0. This is p1 over p2, right? And 1 over n1 over n2. So that would be the z score. And this z score, right? You can see the t table is 1 point something, and this is very large, right? So we reject. I also ask what if the p-value is bigger than this, is almost close to 0. So the confidence interval given is like this, right? It's applying the formula. Thank you.